Good afternoon, my name is Marco,
My name is Amanda.
and we're going to solve the problem number 4.
Implicit differentiation is the process of finding the derivative of a dependent variable in an implicit function by differentiating each term separately. By expressing the derivative of the dependent variable as a symbol, and by solving the resulting expressions for the symbol. This type of differentiation helps us to obtain the rate of change, because it has two variables that change constantly. In this project, we have to know the speed at which a variable changes over a specific period of time.
At 2 a.m., Ship Harvey is 200 miles west of Ship Lydia. Ship Harvey is sailing to the north at 32 miles per hour, and Ship Lydia is sailing to the east at 26 miles per hour. How fast is the distance between them is changing at 6 a.m.
Okay. At 2 a.m. we know that the Ship Harvey is 200 miles west from the Ship Lydia. So we want to know when the Ship Harvey goes to the north with a velocity of 32 miles per hour, and the Ship Lydia goes to the east with a velocity of 26 miles per hour. We want to know what is the distance, like this line, between them at 6 a.m. Okay, so in order to know the value of c, we have to use Pythagoras formula. That is c squared is equal to a squared plus b squared. And we know that b is this one and a is this one, so we just substitute. And because it is to the square, we have to take like the square root of the result. And then we know that the result is equal to 329.85 miles. Okay, now we have to obtain the rate of change, and before we obtain it, we have to know that the velocity is equal to the distance over time. That's why we write it like this formula, and we have like this formula of the rate of change. So we obtain the derivative, and then we multiply it times dx, that it's kind of this. So we have like dc over dt, because we have this one. So we know that dc, the original formula was c squared is equal a squared plus b squared. So derivative is 2c times dx, it's equal to a times dx plus 2b times dx. And then we have all the values except this one. So we substitute it with the values that we have in our chart, and we solve it, and we have this result. But we still have this one that we don't know what is it. So we isolate it, and we just do the result in the calculator, and we got that the final result is 36.38 miles per hour.
As we can see, the distance between the two ships is 329.85 miles, and the rate of change is 36.34 miles per hour.
This project helps us to understand the importance of calculus in real life. The rate of change in real life helps us to get the exact change that may have an object that has been measured with different exact measurement tools. This really helps us in engineering to know what is the change of rate of a wall, so they know if it resists a house, or maybe in the normal life, just for you to know as a data of the rate of change or the exact value of an hula hula, or as simple as the size of our feet.